Hello guys, welcome back to my channel. Today we will be assigning deflection parameters to this structure, to the columns and beams. We are going to be running deflection check. The last class we succeeded in doing member design, and when we analyzed after applying the design parameters, all the members passed. Let me still show you. Go to post processing, quickly go to our utilization ratio, through results, utilization ratio, click on failure. You see no member failed, none of the members failed, so everything passed. So quickly go to the business of the day, which is deflection check. So I'll go back to model and locate my design. Here we are going to specify some deflection limits for members. For column, we have deflection limit of L over 300 according to American code. For cantilevers, we have L over 180, and for beams or horizontal members, we have L over 360. That's according to American code. So I'll quickly come to add parameter. I will click on DFF. That's it says deflection length maximum allowable local deflection. So I'll first type in for my column. I'll write 300 here. I'll say add, click on add. Then I will do for my beam horizontal members 360, L over 360. I'll add. I also do from cantilevers, which is L over 180. I'll add. I will locate can, C-A-N, can. I'll click on can 1. See, I can add. I'll click on, I'll close for now. I'll assign this one to my columns, all the columns. I'll go to select, attributes, property name, select all the columns. This one is beam columns. I'll hold down the Ctrl key. Now locate all the columns. All the columns, yes. Even the ladder, no. Yes. Leave this one. Yes, all the columns. I'll click assign to selected beam. Then for this, I'll assign it to my beams. All the beams, hold down the Ctrl key. All the beams. No, my main beam. Yes, click assign to selected beam. Then this I will assign to my cantilevers. This I will zoom to the left. Hold down the Ctrl key to select these cantilever beams. These cantilever beams. Okay. one is also a cantilever beam. Yeah, there's another one. My main beam is cantilevered as well. That's good. I'll assign to selected view. Then click on can. Assign to all. Assign to view. The next thing is to specify the points where I want my deflection check to be actioned. So before that, I will have to on my node numbers. Say okay. Let me select my columns. Select property name by property. Clear my columns. No. Yes. I'll view only columns. Yeah. So we are going to assign our DJ points. DJ1, DJ5 is for this column, meaning the software should check deflection limit from this point to this point, because at this point this column is braced, this point is braced, so the deflection check will be between these two nodes, which is 1 and 5. So I'm going to create DJ1, DJ5 and assign it to this member. So what it does is the software sees it as a separate member and it performs a deflection check on it. I also specify here to here. So if in my specification I put DJ1, DJ9, the software takes these two columns as one member and performs deflection check on them. So I'm going to create all these DJs and assign it to them. Go to parameter. Okay, we click on DJ1. My DJ1 for this column 1 is 1. I have 1. Click on add. DJ2, we have 5. Click on add. DJ1 again for the second, the other one starting from 5. DJ2 to 9. So 9. Click on add. The other one is starting from 9. DJ1. Click on add. DJ2 from 9 to 13. Click on add. The other one is starting from 13. Click on add. From 13 to 17, DJ2, 17. Click on add. From 17, click on add. From 17 to 21, 21. Click on add. I will do the same thing for other columns, so I will go offline. Okay, I've done that for all the columns. Let's close and assign. So this DJ1, I'm going to assign it to this member 1. DJ5 to the same member. DJ5 to 9, going to this member, to the same member, from 9 to 13 to that member, to the same member, 13 to 17 to that member, to the same member, 17 to 21, assign to that member, to the same member. Okay, that's how I will assign to other ones. So let me go offline. Okay, I've assigned all that to the column. I will do the same thing for the beam, but in this case now I can consider the beam that is critical for me. I might not do it for all the beams. This one here, they are critical for me. Okay. I'll do that for this one at the middle. If this one passes deflection check, this one will pass. Also do it for this one, this center one that has more load. I'll do it for them. Then I will do for this main beam and that main beam. If they pass, then I'm okay, I'm good to go. So I also click here. DJ1, this one will be 23 to 24, 23, add DJ2, 24, add, that's for that one. I will do for the other one, DJ1, 35, to 36, 35, 35, DJ2 to 36. Okay, then I will do for these ones. This is a cantilever, from here to there is a cantilever, so I'm going to consider it as one beam. So it's going to be 25, 21 to 25, DJ1, 21, DJ2, 25. That's good. I will do the same for this. It's going to be 22 to 26, J1, 22, J2, 26. Okay, the main beam, we have a support here and a support here, so the deflection is going to be from 21 to 23, DJ1, 21, DJ2, 23. So in deflection checking, the software is going to consider this point, from this point to this point, as one beam. So it will now give us how the deflection will be like when these loads coming from this grillage beam are being transferred to this other beam. So how is it going to deflect? How is it going to react to the load? That's the perfect thing for me. That's what it's supposed to be. That's the correct thing. So if you can, it's not correct to check deflection from here to here because there's no support from there. There's no support here. There's no support here. There's no support here. This is where we have support. This place and this place. So the deflection check is supposed to be between this and this. So you know how the beam is going to hug when it's loaded. That's the correct thing. Have I added this? 23. Okay. I have not, so let me add. That's good. Then this one is going to be 22. Add 24. 24. Add. Okay. Then the cantilever here, I'll have it as 23. Add 27. Add DJ1. 24. Add 28. And so I'll go and do I'm going to assign them to the beams. So this first one is 23, DJ 23 to 24. We have 23 to 24. That's this. So I'll select this one, assign to selected beam. 24, do the same thing. 25, 26. Okay, 35. This one is 35. Assign. 36. Still the same member. 21, 25. This member. Hold down the control key. 21, 25. Assign. 25. The same member. Assign. 22, 26. 22, 26. Assign. 22, 26. Assign. 21, 23. 21, 23. So I'm going to select all the beam. There's a short beam here. Yeah. Assign 23. The same thing. Assign. We have 22, 24. 22, 24. This place 24. 22, 24. Assign. 22. Need to select the command before selecting the beam. 22, 24, the same number. 23, 27. 23, 27. Sign. 23, 27. Sign. 24, 28. 24, 28. That's good. So okay, I'll bring back my whole model, whole structure. go back to parameter, track. I will locate track, print the design output at maximum detail, track 2, add, close. Then I'll go to check code. Remember what I told you in our previous class? Without this check code, the software will not be able to compare the output results to the code standard. So check code is for the software to compare what is the outcome of the design with what is the code requirement. So that's the essence of this check code. So this one we assign to view. And for this check code, I'm going to select the members that are very important to me. Select attribute property by name. I will my grillage beam, very necessary. My column, very necessary. My main beam, very necessary. So I'm okay. I'll say assign to them. That's good. I will run analysis. While the analysis is running, I will like to use this opportunity to still beg you, if you are watching this video and you are yet to subscribe to my channel, please just take 2 seconds and subscribe. Subscription is very free. Subscribe, like, and share with your friends. Subscription is the only way you can appreciate what I'm doing. You can actually encourage me through that, and when you subscribe, I'll actually be very happy. Thank you. So this is the analysis, this design. We have 0 error, we have 0 warning. So you simply go to output and go to post processing mode. We go to post processing mode, click done. So we have checked every other thing in our previous class. So the major thing we are going to check here now is just the deflection check. So when you click on this utilization ratio, you need to print that of deflection, not for any other thing. We don't have any failed member due to deflection. So let me just check those main members that that are my concern. Very important. Yes, this one, and the main beam. Yes, so I will isolate other ones. You see, okay, let me remove my node number, because if you are seeing 69, you think it is the deflection ratio. Let me off my node number. It is scaring anyway. You're not supposed to have any value there up to 1. Good. So you see, my columns are doing well in deflection. So my beams, this one is 0.8. See, 0.8. The ones carrying the load, are more stressed. You have 0.819, 0.819. Yeah, so see my cantilever 0.1, 0.1, 0.4. Everything is good. You are good to go. You are very much good to go. So this is the end of this design, the end of water tank, elevated water tank structural design. In our next class, we'll be doing foundation design. Depending on when you are watching, can check my channel, maybe it is already there. We're going to do foundation design. We are also going to do connection design, base plate, and the rest of them. A lot of things we are going to be posting on my channel. So if you are not subscribed, you'll be missing it. You will not even know when those things are being dropped. It still depends on when you're watching. You can still go and check my channel now and check if to see if those things are already there. Yes, check other classes. I'm also going to give out this start file to those that are interested. I will do a short video on that, and just stay tuned. I'll give it out to those that are interested, my subscribers that are interested to have them. I'll give out these ones I have done. You have it in your system. Yeah. So this design is good. So far so good. I'm very happy. Thank you for joining me, and stay tuned. See you next time. Thank you.